Guys, in this video, we will be learning what is intrinsic NumPy 2D array creation function in Python. In last video, we covered one-dimensional array functions wherein we discussed two functions, arrange and linspace. So in this today's video, we are going to discuss three functions. NumPy has over 40 built-in function for creating arrays as laid out in the array creation routines, right? So these function can be split into three categories like you have seen 1D array already, 2D, two dimensional and then ND arrays. Okay. We are going to see this function one by one. I have PyCharm editor Python version 3.12 installed on my machine. So now get started with the tutorial. Okay. Before implementing anything with NumPy library, you have to import NumPy library. If you want to see whether NumPy library is installed on your machine or not. Either you have to open terminal on the PyCharm and then type in one command pip list. It will show you the total libraries installed on the machine, or you can go to your physical location of the project and open command prompt and type same command. Okay, so you will see. Okay, or we have another way to see what are the packages. If you go to the Python packages in PyCharm, so you will see all installed packages on the machine, right? So we have installed NumPy 1.26.2 version and we have to import it. So NumPy I function defines a 2D identity matrix, right? The element where I equals j, these indexes values are 1 and then rest are 0 in the matrix. Okay, if you want to implement it, NumPy alias of NumPy array1. Let me open the documentation of I function. Okay, so you will see these are the arguments of I function and this is the information about this function. So if you see n, what is the first argument of this method? That is number of rows in the output, right? Let me take 2, number of row I want to display 2. Second argument, what we have number of columns. Okay, if you pass 2 into 2 matrix, then we have to say the index of the diagonal, which index you wanted to start your diagonal elements. Let me take 0, and if you print array 1, and before that if you wanted to see which type of array it is returning the object, so you will get to know this is ND array, right? Okay, so you will see this is ND array, it is returning the I function. Okay, and if you see what is it is returning ND array of shape n and m, right? Rows and columns. Okay, it is returning diagonal 2D array. Okay, right? So if you see it is two dimensional array. Okay, this is first dimensional and then in this we have another array, right, as a element. So this is called two dimensional array, that is it comes in the two dimensional array. And if you observe a diagonal element, that is 1, right? Rest of the element would be 0. Okay, if you make 3 into 3 matrix, so you will get 3 into 3 matrix with diagonal's value would be 1. Okay, if you want to start your diagonal position with other index, let me take first. So you will see your diagonal index started with first position, not 0th position, right? If you want to change the matrix 5 multiply by 5, then you will see the diagonal element would be still 1. Okay, and these are the diagonal values. Okay, so the purpose of I function to create diagonal elements with one value, rest elements of the matrix would be 0. Okay, if you see the documentation of this one, right, so we have d type also you can pass on. Let me take float. Okay, if you run it, we will get the float values, right? Okay, or you can see int, right? So we have one order also, that is one other argument. If you see the order, it would be C or F as a character. So if you provide the f, so it will order your elements in memory. Okay, asterisk we have, like we have. Now jump to our next method, that is diagonal. What is diagonal method? It can define either a square 2D array with given value along the diagonal, or if given a 2D array returns a 1D array, that is only the diagonal element. Okay, the two array creation function can be helpful while doing linear algebra. Okay, so how we can use this function, array2, and then you say np dot diag diagonal values this. Okay, let me take 4 5. Okay, so what it would create, it would create 5 into 5 matrix, and diagonal values would be 1 2 3 4 5. Okay, and then if we want to print, it will generate the matrix like this. You see, it is two dimensional array, right? In this first element of the array, we have this complete matrix that contains the diagonal element as we have said. Okay, if you want to make it less, then it will create 3 into 3 matrix, 1 2 3. Right, so in this function also we have which position we want to start our diagonal, right? One, start with first index. My diagonal values would be starting with first. Okay, so you see first, not 0. Previously, by default, it was on 0th position. So this is the diagonal function. Or if you want to provide any of your array, and I'm creating simple numpy array that is two dimensional. Okay, we have defined it will return nd array again, and we'll be taking other array 4 variable and would be creating the diagonal. Okay, we will getting the diagonal elements array. Okay, array 3 will be passing here, so it will return the diagonal array to us, right, in form of nd arrays object. Let me take array 4 as a output and then run it. Okay, so what would be the output? It would be the output 2 and 7. Okay, the diagonal array would be 2 and 4. If you want to print array 3 also, so you will get the matrix, right? You will get, if you see its documentation of diagonal, so you will get the information. So extract a diagonal or construct a diagonal array, right? So as I said you, so it will extract a diagonal and wish to write to the resulting array, right? So we extracted diagonal matrix, okay, from here. So you can see more information over here and you can use it, you can try it. Okay, let's see other method, that is vendor method. It defines a vendor monde matrix as a 2D numpy array, right? You know vendor monde matrix, it is nothing but it describes the linear algebra interpolation program of finding the coefficients, right? What it does actually, each column of the vendor monde matrix is a decreasing power of the input 1D array or list or tuple, right? So let me show you array 5. Okay, this is my array np dot vendor. I'll be passing a list over here and give me the 3 or 2 or any column output. Okay, this is, and then we'll be printing array 5. Okay, let's in the program. So you will get to know what it is doing. It is actually giving us the number of columns we have provided, and it is saying it will create the power of the element, right? If you pass on 3, then you will see, so in each column it will give us the power of these numbers, right? 1 2 3 4. So it is creating 3, means it is creating 3 columns, and these are the rows, total rows. So how it is working? Okay, if you make it 4, the matrix is changed now into the 4 columns. 5, right? You see, into 5. We want to see its documentation, so you will get, this is the vendor generate a vendor mounted matrix, right? Columns of the output matrix are powers of the input vectors, right? As I said, this will create the power of input vectors, right? So these are our input vectors, and we are creating the power into the column, right? In each columns it is showing us. Okay, and order of the power is determined by the increasing. Okay, by default it is false. If I make increasing equals to false, then let's see what it returns. So if we make it true, by default it is false. Let's make it true. Then so you see it changes the way of generating the powers of input vector, right? It is now starting from 1 and then 4, 16, 64, these elements. Okay. So this is the purpose of this argument. Okay. If you want to use linear space function also here, you can use it easily. Dot vendor. Okay. And then I'm saying np dot linear space. Here I'm saying I want to start with 1. I want to stop at 10. And then I'm saying number of samples. Okay. Let me make it 3. If you print array 6, basis on that you will get the output. Okay. So here if you see, so I'm generating 3 samples, right? 3 samples here, and each 3 sample I have passed into the vendor. So you are getting the powers of the vector, right? You see 1 5, because linear space actually generates the interval itself. We do not have any control, right? So whatever elements values generated, so based on that we have created the matrix. Okay, these are all two-dimensional arrays. I hope you found this tutorial useful. If you have any doubt, if you have any query, you can leave your queries into the comment box and we will cover those query in the upcoming videos. Okay? That brings us to the end of the today's video. We hope you found it informative and engaging. Don't forget to subscribe to our channel for more exciting content on all things tech related. Thanks for watching and we will see you in the next video.